All right, we're starting with the 3.6 notes. Today we're going to be talking about compound inequalities. All right, so we're going to skip this first page of notes and we're going to move to the next page. All right, actually we're going to skip to page 39 of the notes packet. All right, so here we're going to get to how to graph these compound inequalities. Then we want to represent the solution, again, using interval notation. Again, compound inequalities are inequality statements that have more than one inequality. So again, for all these compound inequality situations, we're going to have two inequality symbols. Now, the arrangement of the symbols with the numbers, and you're going to see here some words, right, does determine how you're going to graph on a number line and how you're going to write that interval notation. So here, for example, 2 part A, we are looking to graph this compound inequality. It says to graph x such that -6 is less than or equal to x is less than 8. So again, from earlier in the unit, we talked about when you're graphing on a number line, the difference between open circle and closed circle. The way you want to interpret these compound inequalities in terms of a graph is that you want to look at one inequality symbol at a time. So here I've highlighted this left half of the compound inequality. And you notice that we have the less than or equal to inequality in that half. And we talked about before, when there is an or equal to option, that means on the number line, we're going to be using a closed circle. Right, so putting a closed circle on -6. And if we look at the right half of the compound inequality, we have x is less than 8. Again, because we don't have the or equal to option, that means on 8, we're going to put an open circle. All right, so now for this type of compound inequality, now we need to figure out where to graph, where to shade on this number line with respect to the closed circle and the open circle. Well, again, if you notice in this particular compound inequality, the x is in the middle. All right, so that is where we're going to shade. Between the closed circle and the open circle, we're going to shade that number line. Now, to see that we shade it in the correct place, and we want to pick a number that's on that shaded part and see if it works for the compound inequality. Like, for example, if we picked 2, right? +2 is definitely right here in that shaded part of the number line. So if I take that 2 and I plug it in for x, then we're looking at a statement that says -6 is less than or equal to 2 is less than 8. All right, again, looking at that compound inequality, we say, yes, that works. All right, -6 is definitely less than or equal to 2, and then 2 is definitely less than 8. So here's a value for x that works for both inequalities. All right, so now we need to write the interval notation. So unlike the previous graphs where we always had the shaded part going infinitely to the left or infinitely to the right, right? We don't have that big old arrowhead on either side. All right, so what I said before is that when it comes to writing interval notation, right, you want to match your graph. Okay, so since we have the graph already done, let's take a look. On the left end, we have -6 with a closed circle. So again, that means we're going to do the bracket, squared off bracket, right, and a -6 next to that squared off bracket. On the left side of that shaded graph, we have 8 with an open circle. So we're going to put 8 on the right And because it's open circle, we are going to use parentheses. Okay, so again, this interval notation does not use infinity or negative infinity because, again, looking at our graph, we do not shade infinitely in any direction. All right, moving on to part B. So here we have a compound inequality. But this time we have the word or that's separating out the two inequality statements. Okay, so let's see how we're going to graph this compound or situation. Left half of that compound inequality says x is less than 1. So here's the graph for that, right? Open circle on 1, and since it's less than, we're going to shade infinitely to the left. That right half of the inequality says x is greater than 8. So open circle on 8, greater than means we're going to shade to the right infinitely. So here's our graph for the compound or. This is our final graph for this particular compound situation. So now we need, and you notice before we actually get to the interval notation, you notice that it is what I call a split graph. Okay, so that's going to kind of match our interval notation. We're going to write an interval notation that is split just like this graph. So we're going to start off by writing the interval notation for the left half of this graph. So we got negative infinity, comma 1 in parentheses for the left half. And I'm also going to write an totally separate interval notation for the right half. Open circle on 8. So I have parentheses 8, comma, positive infinity, because that arrow is going infinitely to the right. Okay, so you see for this particular compound or situation with a split graph, you are having to write an inequality that, an interval notation that is split into two separate ones. All right, again, unlike part A, where we only had to write one inequality, for this compound or, we're going to have to write two separate ones. But because we want both of these inequalities as part of our solution, we need to connect these two interval notation setups, and we're going to connect them with this symbol right here, right? Like this big giant U, capital U, which represents the word union. Okay, so union means together, so we want both of these interval notations together to make up our final answer. All right, now moving on to part C, you're going to notice again, it is a compound inequality that is split. All right, but this time, instead of the word or, we have the word and. Now, recognition of this is very important when you're looking to do the graph and the interval notation. All right, so like I did before, I'm going to graph each of these separately. Here we have x is greater than 2. So we've got open circle on 2. Greater than means we're going to shade to the right. Now I'm also going to graph on the same number line, the second half, x is less than 6. So that means we have to put an open circle on 6, and because it's less than, we need to shade to the left. Now we're looking at our graph, and we kind of see, right, a lot, like basically the whole number line shaded. But we need to be careful on how we interpret what we want from this graph, because we cannot leave this as our final graph. All right, so what I'm going to do is I'm going to redo this graph, but this time I'm going to use different colors. All right, so again, we're going to do this one more time. X is greater than 2, so we're going to put an open circle on 2, and we're going to shade to the right. For x is less than 6, I'm going to use my blue highlighter. So again, we're going to put an open circle on 6, and we're going to shade to the left, because x is less than 6, we need to shade to the left. All right, so the reason why I use the two different colors is that we want to understand for the compound and, what exactly are we looking for in terms of the graph? Well, in terms of the graph, we are looking for where the two different shadings overlap. Right? So you notice that in this area where it is green, right, because yellow and blue make green, that is going to represent our final answer, our final graph for this compound inequality. Again, for the compound and, in terms of the graph, we want where the shadings overlap. So that means that I'm going to have to erase anything that's just blue and anything that is just yellow. And so this is what we want for our final graph, where the two shadings overlap. So between 2 and 6, that's what's shaded. All right, so to make that clear on like a test for this unit, what I'm going to have to do is I'm going to have to kind of draw a clean graph. Because you may not have this opportunity to be able to erase and redo on a number line. So, right, I'm going to put 2 here with an open circle. I'm going to put 6 here with an open circle. And I'm going to shade just in between, right? That's where the two shadings overlap, between 2 and 6. Okay, so again, I need you to do that for the quiz and test for this unit, right? Because you might not have highlighters, right? What I want you to be able to do is to communicate to me what is your final graph, what is your final solution. Okay, so in terms of an inner notation, again, we look at open circle on 2, so it's parentheses 2, and an open circle on 6 on the right, so parentheses next to the 6, right? Again, no infinity in interval notation for this one, because again, looking at our final graph, we do not have any arrows going in either direction. All right, moving on to example 3. Here we're given the graph, and we're asked to write the compound inequality and the interval notation. So again, recognition of an association of these different graphs with the compound inequalities is key. So we see here for part A that this graph is split. So which compound inequality do you think we're going to associate with this split graph? All right, if you said or, then you are correct. So let's first write the compound inequality for this graph. So again, we know that we're going to have the word or in there, so I'm going to write that on the line already. So on the left half, we have, all right, 3 as the biggest number, and it's shaded to the left. So here we're looking for all x values that are smaller than or equal to 3. Again, we have the or equal to option here because there's a closed circle on 3. On the right half, we have all the numbers shaded to the right of 4. So that means we want x values that are greater than 4. No or equal to option here because we do not have the closed circle on 4. We have an open circle on 4. All right, again, underneath, there is the interval notation. Okay, so let's see what you can do with the remaining 3. Again, you want to write the inequality that goes with the graph, as well as the interval notation. Okay, so let's see what you did for part B. Part B, we see that it is all shaded in between. For your inequality, it will be where we have the two inequalities with the x in the middle. All right, so those are the numbers you have for that one and the interval notation. Split graph for C, so there's an inequality and the interval notation. With part D, because it's shaded in between, we have x's in between two inequalities. Again, there's your interval notation.